Today's topic is multiple regression equations when the deviations are taken from actual means. Let x1 bar, x2 bar and x3 bar be the actual means of the three variables x1, x2 and x3 respectively. The calculations involved in solving these regression equations are considerably reduced if the deviations of the various variables are taken from their respective means. So, if x1 equal to x1 minus x1 bar, x2 equal to capital X2 minus capital X2 bar, and x3 is equal to capital X3 minus capital X3 bar. The multiple regression equation takes the following shape. x1 is equal to b 12.3 x2 plus b 13.2 x3. We can also find the values of B12.3 and B13.2 by simultaneously solving the equations. Summation x1 x2 which is equal to B12.3 summation x2 square plus B13.2 summation x2 x3 and summation x1 x3 is equal to b 12.3 summation x2 x3 plus b 13.2 summation x3 square. The values of B12.3 and B13.2 can also obtained by B12.3 is equal to R12.3 into sigma 1.23 divided by sigma 2.13 and B13.2 is equal to R13.2 into sigma 13.2 divided by sigma 3.12. Similar calculations are possible for the regression equations of x2 on x1 and x3 and for regression equations of x3 on x1 and x2. The next topic is standard error of the estimates for multiple regression and multiple correlation. Multiple regression. The reliability of the estimates obtained through regression equations is studied through the calculation of standard error of the estimate. The standard error of the estimate of x1 on x2 and x3 is S 1.23 is equal to root under summation x1 minus y1 whole square divided by n minus 3, where S 1.23 is the standard error of the estimate of x1 on x2 and x3. x1 is the original value of x and y1 is the estimated value on the basis of the regression equation. Multiple correlation. The standard error of the estimate in terms of the correlation coefficients R12, R13 and R23 is S1.23 is equal to sigma 1 root under 1 minus R square 12 minus R square 13 minus R square 23 plus 2R12 R13 r23 divided by 1 minus r square 23. If it is proposed not to calculate the estimated values of x for all data points and also not to calculate the partial correlation coefficients, the standard error of the regression estimate is S1.23 is equal to root under summation x1 square minus a summation x1 minus b1 summation x2 x1 minus b2 summation x2 x1 divided by n minus 3. The standard error is an estimate of unexplained variations in the values of x. If the total variations of x1 is divided into two parts, the standard error would represent the unexplained variations. The explained variations would be due to the independent variables. Here are a few examples. Given R12 is equal to 0.28, R23 is equal to 0.49, R31 is equal to 0.51, sigma 1 is equal to 2.7, sigma 2 is equal to 2.4 and sigma 3 is equal to 2.7. Find the regression equation of x3 on x1 and x2. The solution. The regression equation of x3 on x1 and x2 is given by x3 is equal to b 31.2 x1 plus b 32.1 x2. B31.2 is equal to sigma 3 divided by sigma 1 into R31 minus R12 into R23 divided by 1 minus R square 12, which is equal to 2.7 divided by 2.7 into 0.51 minus 0.28 into 0.49 divided by 1 minus 0.28 whole square, which is equal to 0.405, and B3 2.1 is equal to sigma 3 divided by sigma 2 into R23 minus R12 into R13 divided by 1 minus R square 12, which is equal to 2.7 divided by 2.4 into 0.49 minus 0.28 into 0.51 divided by 1 minus 0.28 whole square is equal to 0.424. Substituting the values, we get x3 is equal to 0.405 x1 plus 0.424 x2, which is the required regression equation of x3 on x1 and x2. The next example. Given the following data, R12 is equal to 0.8, R13 is equal to 0.7, R23 is equal to 0.6, sigma 1 equal to 10, sigma 2 is equal to 8, and sigma 3 is equal to 5. Determine the regression equation of x1 on x2 and x3. The solution. Let x1 and x2 and x3 be the respective deviations from the means X1, X2 and X3. Regression equation of x1 on x2 and x3 is x1 will be equal to b12.3 x2 plus b13.2 x3. So b12.3 is equal to sigma 1 by sigma 2 r12 minus r13 into r23 divided by 1 minus r squared 23, which is equal to 10 by 8 into 0.8 minus 0.7 into 0.6 divided by 1 minus 0.6 whole square, which is equal to 10 by 8 into 0.38 divided by 0.64, which is equal to 3.8 divided by 5.12, which is equal to 0.742. Next, B13.2 is equal to sigma 1 divided by sigma 3 into R13 minus R12 into R23 divided by 1 minus R squared 23, which is equal to 10 by 5 into 0.7 minus 0.8 into 0.6 divided by 1 minus 0.6 whole square, which is equal to 2 into 0.22 divided by 0.64, which is equal to 0.44 divided by 0.64, which is equal to 0.6875. Substituting the values, we get x1 is equal to 0.742 x2 plus 0.6875 x3. The next example, given R12 is equal to 0.28, R23 is equal to 0.49, R13 is equal to 0.51, sigma 1 is equal to 2.7, sigma 2 is equal to 2.4, sigma 3 is equal to 2.7. Find the regression equation of x3 on x1 and x2. Required solution. The regression equation of x3 on x1 and x2 is given by x3 equal to b 31.2 x1 plus b 32.1 x2. Now b 31.2 is equal to sigma 3 by sigma 1 into R23 minus R12 into R13 divided by 1 minus R square 13. This is equal to 2.7 divided by 2.7 into 0.51 minus 0.28 into 0.49 divided by 1 minus 0.49 whole square equal to 1 into 0.51 minus 0.1372 divided by 1 minus 0.2401, which is equal to 0.3728 divided by 0.7587, which is equal to 0.49, and B32.1 is equal to sigma 3 by sigma 2 into R23 minus R12 into R13 divided by 1 minus R square 13, which is equal to 2.7 divided by 2.4 into 0.49 minus 0.28 into 0.51 divided by 1 minus 0.51 whole square, which is equal to 2.7 divided by 2.4 into 0.49 minus 0.1428 divided by 1 minus 0.2601, which is equal to 2.7 into 0.3472 divided by 2.4 into 0.7399, which is equal to 0.93744 divided by 1.77576, which is equal to 0.528. Hence, substituting the values, we get x3 is equal to 0.49x1 plus 0.528x2.